you probably bought something from Amazon recently. I mean, think about it.
Yeah, I definitely have.
Right. Maybe it was, I don't know, a new book or some obscure electronic part for a project.
Or maybe you're like a lot of us, and you found yourself ordering a tiny, seemingly essential desk humidifier at exactly midnight.
Oh, absolutely. Guilty of that one. And, you click a button, a box shows up at your door 2 days later, and your part in the transaction is basically
It's
over.
really over, yeah.
But if you take a step back and really think about the digital plumbing that makes that happen, it begs this massive, almost absurd question.
Mm-hmm.
How did the exact same company that ships you a midnight humidifier end up running the underlying compute infrastructure of the entire internet?
It really is a staggering thought when you step back from the retail storefront.
Right.
Because we interact with the e-commerce side of Amazon all the time. But the invisible engine powering countless other apps, massive enterprise databases, and, well, even secure government systems is Amazon Web Services, or AWS.
Yeah.
The digital world essentially runs on their physical hardware.
And to understand how a literal bookstore managed to pull that off, we are jumping into a really unique source for our deep dive today.
Rare.
It's an article by Aaron Rose, and it's titled The Secret Life of AWS, The Problem Before the Cloud. It was published on the tech-reader blog. And honestly, the format of this piece is actually what makes it so compelling to me.
Oh, for sure. It completely avoids the trap of reading like some dry technical white paper.
Yes.
It reads much more like a narrative, right?
Mm-hmm.
The author frames the entire history as this conversation between two characters.
Mm-hmm.
You have Margaret, who is this seasoned senior software engineer with a lot of battle scars from the early days.
Yeah, she's seen some things.
Definitely. And then there's Timothy, her highly capable but much younger junior colleague.
Right.
And they are having this deep technical discussion against the rainy backdrop of a grand Victorian library in London.
I love that setting.
It's great. It creates this wonderful atmospheric contrast. You have the heavy physical world of old books, leather bindings, and tangible craftsmanship surrounding them,
while they dissect the entirely invisible, hyper-scalable world of modern cloud computing.
Exactly. It's brilliant framing.
So our mission for this deep dive is to basically follow their conversation to uncover the hidden infrastructure crisis that birthed the modern cloud.
Yeah.
We want to understand how a desperate internal fix at a chaotic online bookstore accidentally revolutionized how the entire world builds technology.
Quite a story.
It is. But to get there, we have to rewind the clock to roughly the year 2000.
Back to the .com era.
Right. At this point, Amazon was not the frictionless, well-oiled logistics machine you know today. They were experiencing severe, almost terminal growing pains.
Oh, absolutely.
They were expanding wildly from just selling books into multiple product categories, and their internal software architecture was just buckling under the weight.
Yeah, and Margaret actually explains this to Timothy by describing the brutal reality of software development at that specific time.
Mm-hmm.
Like if an engineering team at Amazon wanted to build a new feature or launch a new service, they couldn't just sit down and write the application code.
Right, which sounds crazy today.
Completely crazy. The friction was immense. They had to physically provision the servers, configure the networking, set up the database clusters, and secure the storage architecture.
Wow.
Yeah, they were building the entire underlying hardware stack and the software to manage it completely from scratch every single time.
Okay, let's unpack this, because the sheer inefficiency of that process is, it's hard to wrap your head around if you're used to modern workflows.
It really is.
So imagine you decide you want to cook a brand new recipe for dinner.
Okay, I'm with you.
But before you can even chop an onion or preheat the oven, you have to physically lay the brickwork for the oven.
Right.
You have to run copper piping for the sink. You have to wire the electrical grid for the kitchen appliances.
Sounds exhausting.
It is. And then your roommate decides they want to make a sandwich.
Okay.
Instead of using your perfectly good kitchen, because your kitchen is sealed off and customized only for your specific recipe.
Oh, I see where this is going.
Right. They go into the next room and build an entirely separate kitchen from scratch with their own plumbing and wiring just to make a turkey club.
That is the perfect analogy for monolithic siloed development. I mean, it is extraordinarily wasteful.
It's insane.
You are spending 80% of your engineering hours building and maintaining the digital kitchen and only 20% actually cooking the meal.
Right. Writing the actual code for the customer.
Exactly. Team A would build their infrastructure, Team B would start a new project and build exactly the same infrastructure again, maybe using a slightly different database schema or networking protocol.
So nobody's sharing anything.
Nobody. Nobody had a unified picture of the entire system, and the compute waste was astronomical. They were simply growing too fast to keep pouring concrete every time they wanted to test a new feature.
Which naturally forces a breaking point.
Mm-hmm.
And that arrived in 2002 in the form of what has to be one of the most ruthless and consequential pieces of corporate communication ever sent.
Oh, the legendary Jeff Bezos mandate.
Yes, the API mandate.
This is foundational lore in software engineering. To stop the internal chaos, the directive was sent out that every single team at Amazon had to expose their data and functionality through formal service interfaces.
Let's pause on the technical mechanism there because service interface can sound a bit like corporate jargon.
Sure.
What he was actually mandating was a shift to a microservices architecture.
Exactly.
He was telling teams they could no longer just reach into another team's database to grab the information they needed. Because that kind of tight coupling is exactly what makes large systems fragile, right?
Oh, totally. If Team A changes their database structure, Team B's code instantly breaks.
Right.
And that's exactly the fragility the mandate was designed to kill. So all communication between teams now had to go through an API.
An application programming interface.
Right. An API acts as a strict, heavily documented contract. Team A says, if you send us a request formatted exactly like this, we will send you the data back formatted exactly like that.
Mm-hmm.
What happens inside Team A's black box, like how they store the data, what servers they use, is entirely their business.
They just have to meet the contract.
Exactly. And there were no exceptions allowed, no back channels, no direct database reads. Everything had to be designed as if external third-party developers were going to use it.
And if you didn't comply,
well,
you were fired.
Yeah.
The source notes that the precise wording of the threat might have softened into mythology over the past 2 decades, but the mandate itself and the architectural revolution it forced is undisputed. They had to fix the internal plumbing, or else.
But, the threat of termination isn't even the most interesting part of the mandate. No, it's the byproduct of that strict isolation.
Oh, interesting.
Because they had to expose all their internal systems as these proper standardized API contracts. They had to make them incredibly reliable. They had to write pristine documentation. They had to handle error logging consistently. They were forced at gunpoint, essentially, to treat their own messy back-end infrastructure as a highly polished, standalone product.
Which naturally leads to the big realization. Once your internal architecture is decoupled and internal teams are communicating over standardized web interfaces, the boundary between an internal user and an external customer becomes completely arbitrary.
Yes. The infrastructure is just an endpoint waiting for a request.
Right.
What's fascinating here is how the source actually dismantles the mythology surrounding what happened next.
Okay, let's get into this.
Because there is a very common tech legend that assumes Amazon executives basically stood in a server room, looked at all this beautifully decoupled infrastructure, had a sudden stroke of genius, and boldly pivoted to invent cloud computing.
Like they were just seers looking into a crystal ball.
Exactly. The narrative is often framed as this visionary moment where they foresaw the future of the internet.
Wait, I don't buy that altruistic visionary narrative entirely.
Good, you shouldn't.
Because if you have just spent years solving the single biggest headache in software engineering, if you have this battle-tested, hyper-scalable system keeping your e-commerce site afloat while your competitors are still crashing under heavy traffic,
Right.
why on earth would you hand your secret sauce over to the rest of the world? Why not just keep that massive operational advantage strictly in-house?
And that is the exact tension Margaret brings up in the article.
Yeah.
The reality of the pivot was much more grounded in brutal economics than some visionary master plan.
Okay.
Amazon built this highly reliable infrastructure out of pure necessity. They were an e-commerce company, which meant they lived and died by the Q4 holiday shopping rush.
Oh, right. Black Friday, Cyber Monday.
Exactly. They had to provision enough physical servers to survive the massive spikes in traffic during November and December.
But the problem with buying physical hardware for your absolute peak traffic is that for the other 10 months of the year, those expensive machines are just sitting there.
Doing absolutely nothing.
Completely idle, burning electricity, and depreciating in value.
Right. And the grand insight Amazon had wasn't just, hey, we have excess capacity, let's rent it. The insight was looking at the wider tech landscape and realizing that every single startup and every single enterprise was suffering from the exact same capital expenditure nightmare.
Wow.
Every new tech company with a brilliant software idea was spending massive amounts of venture capital, leasing data center space, racking physical servers, and hiring sysadmins before they wrote a single line of code that actually touched their product.
So the great realization was that infrastructure was a universal obstacle.
Yes.
The infrastructure was not the product. And because Amazon had already built the solution to that obstacle just to save themselves, they had a highly mature product ready to deploy.
Exactly. As Margaret points out to Timothy, a service built by engineers who desperately need it to work for their own late-night survival is fundamentally different from a service built speculatively by a vendor hoping someone might buy it.
Right.
Amazon was its own most demanding customer.
So they take this internal toolkit, polish the edges, and in 2006, AWS officially launches to the public. But they didn't launch with the hundreds of highly specific, complex services they offer today.
No.
They started with just 3 foundational primitives, the literal building blocks of any digital architecture.
Right. The first one out the gate was SQS, or Simple Queue Service.
Okay.
This is a messaging system, which, might sound underwhelming until you realize it solves the decoupling problem we just talked about.
Right.
SQS allows different parts of an application to send messages to each other asynchronously. So if your checkout service is completely overwhelmed, it can just drop messages into a queue, and the inventory service can process them at its own pace without the whole system crashing.
Okay, that makes sense. And then came S3, the simple storage service.
Yeah.
And we really need to elevate how we think about this one. It wasn't just a digital hard drive.
Not at all.
It was highly durable object storage built to handle massive amounts of unstructured data. You didn't have to pre-allocate space or worry about RAID configurations. You just sent a file via an API call, and AWS handled the replication and redundancy across multiple physical facilities.
It was revolutionary. And finally, later in 2006, they released the service that truly changed the world.
Right.
EC2, or Elastic Compute Cloud, this was the compute layer. Instead of waiting 3 months for Dell to ship you a physical server, you could make an API call and have a virtual server booted up and ready to run your application code in 3 minutes.
Let's talk about the mechanism of EC2, because virtualization is really the magic trick of the cloud here.
It really is.
AWS wasn't assigning you a dedicated physical machine. They were using software called a hypervisor to slice up massive, powerful physical servers into smaller, isolated virtual machines.
Right.
To the developer, it looks and acts exactly like a standalone Linux or Windows server. But in reality, it's just a software process running alongside dozens of other virtual servers on the same exact silicon.
And you were billed by the hour.
Wow.
When your traffic spiked, you just spun up 10 more virtual instances. When the traffic subsided, you terminated them and they simply vanished. The billing stopped instantly.
That is wild.
Storage, compute, and messaging. The 3 primitives.
Here's where it gets really interesting, because the technology itself was only half the revolution.
Yeah.
The real shockwave was the paradigm shift in the business model.
Yes.
It was the shift from capital expenditures to OpEx, or operational expenditures.
The financial model was completely inverted?
Right. Think about it like this. Imagine you throw a massive 100-person New Year's Eve party once a year.
Okay.
Under the old bare metal server model, it's as if the city required you to buy the land and physically construct a multi-story concrete parking garage on your property, just in case all 100 guests decide to drive their own cars on that specific night.
Which is ridiculous.
Exactly. It costs a fortune, it takes months to build, and for the other 364 days of the year, you have a massive, empty, expensive concrete structure sitting in your yard doing absolutely nothing.
It's a massive drag on your capital.
Exactly. But the EC2 model is like discovering you can just hire a highly efficient valet service for New Year's Eve. You pay them by the hour, strictly for the exact number of cars that actually show up, and the next morning the valets leave, the extent stops, and you don't own a parking garage.
That captures the operational relief perfectly. But the source makes a crucial point here.
What's that?
In 2006, this shift was not met with universal applause.
Oh, really?
Yeah, there was immense deep-seated distrust from traditional systems administrators and infrastructure engineers.
Well, which is entirely
Uh,
understandable. I mean, if your entire professional career is built on understanding hardware, knowing exactly which rack your server is in, physically running the Ethernet cables, controlling the heat and power, suddenly handing all of that over to an API endpoint controlled by a retail company must have felt terrifying. You are trading physical control for software convenience.
And Margaret tells Timothy that the fear of giving up that bare metal control was entirely rational. If AWS goes down, you go down, and there is absolutely nothing you can do but watch the status dashboard.
Right.
But if we connect this to the bigger picture, the cloud didn't win because it was an inherently flawless utopian system.
No.
No, it won because the alternative was financially and operationally untenable. The alternative was spending millions buying hardware that is obsolete in 3 years, paying teams to manage cooling and power, and watching those expensive assets sit idle during off-peak hours.
Yeah.
Faced with those brutal economics, renting invisible, virtualized compute power suddenly looks very appealing, even if it means you can't physically hug your servers anymore.
And that transition to invisible infrastructure naturally created an entirely new generation of software engineers.
It really did.
This is where the narrative loops back to Timothy, sitting in that rainy library. Timothy is the archetype of the modern developer. He started his career long after the cloud wars were actually won.
Right. For Timothy's generation, infrastructure is just code. It is entirely abstract. He uses deployment tools to write a few lines of configuration, and he just assumes the load balancers, the storage buckets, and the compute instances will magically materialize.
That magic.
Exactly. He has never had to calculate the physical thermal load of a server rack or deal with the panic of a hard disk physically degrading. The hardware layer has been completely abstracted away.
So what does this all mean for the people actually building the software we use today?
Whoa.
The source points out a really beautiful irony here. AWS, and specifically the Bezos API mandate, was designed so that people like Timothy would never have to think about the physical layer. The entire goal of cloud computing is to free developers from the burden of infrastructure so they can focus entirely on solving business logic. The abstraction hiding the messy physical reality of blinking lights and spinning disks behind a clean, simple web interface is the entire point of the product.
But there is a massive catch, and this raises an important question.
Okay.
It's the core piece of wisdom Margaret imparts to her junior colleague. She warns him about the abstraction trap.
The abstraction trap.
Right. Because the cloud is so seamless, it is incredibly easy to treat it as magic. But relying on an abstraction without understanding the underlying mechanics means you are forced to accept whatever default configurations the system provides.
Ah.
And in cloud computing, unexamined defaults are incredibly dangerous.
They are dangerous because the abstraction hides the financial reality of what you are actually doing.
Right, exactly.
Margaret points out that taking the easy defaults will quietly cost you a fortune because you are renting compute power by the hour and because the system is designed to scale infinitely and automatically.
boy.
A small misunderstanding of the mechanics can trigger an absolute disaster.
Oh, we see this happen constantly in the industry. Let me give you an example.
Yeah, please.
A junior developer writes a slightly inefficient piece of code and sets up an auto-scaling group tied to CPU usage. They deploy it on a Friday afternoon and go home for the weekend.
Oh, no.
Right. Over the weekend, a minor bug causes the CPU usage to spike.
And the cloud does exactly what it was instructed to do.
Precisely. It assumes the application is under heavy traffic, so it automatically provisions another high-memory virtual server.
Wow.
And then another, and another. Because the developer doesn't understand the physical compute load they are requesting, they don't realize they have just spun up 500 massive servers.
Just to run a bug.
Exactly. The abstraction hid the reality. And on Monday morning, the company wakes up to a $100,000 AWS bill for a zombie fleet of instances that spent the weekend doing nothing but running a broken loop.
Man, that is the ultimate double-edged sword.
It really is.
And that brings the entire history full circle. The strict ultimatum that Jeff Bezos sent out in 2002, the mandate to completely decouple internal teams and treat infrastructure as an API contract, successfully stopped Amazon from collapsing under its own weight. But in doing so, it created the very abstraction that the entire global tech industry relies on today.
It's a fascinating evolution, really. The desperate need to just survive the holiday shopping volume as an online bookstore accidentally provided the architectural blueprint for modern software.
It's wild.
The fact that banking systems, streaming platforms, and global logistics networks are all running on a framework born from a desire to stop building redundant digital kitchens, it's incredible.
It really highlights that the frictionless convenience of the cloud, which we all interact with every single day, is just a brilliant illusion.
Yep.
It is a highly polished, heavily documented surface designed to hide a sprawling, chaotic, heavily air-conditioned physical reality.
The convenience is unparalleled, but Margaret's warning remains true. The abstraction is only safe if you understand what it's hiding.
And that leaves us with something really important to think about as we wrap up this deep dive.
Yeah.
AWS won the internet because it successfully hid the messy, expensive hardware layer from us. It turned the most difficult parts of running technology into invisible, scalable defaults.
Mm-hmm.
But we are seeing this exact same pattern of abstraction happening everywhere now, from the massive artificial intelligence models we are integrating into our daily lives to the complex algorithmic financial systems we rely on.
Right.
More and more of our world is becoming highly abstracted and managed entirely by a few massive third-party giants.
We are essentially outsourcing the complexity of the modern world.
We really are. So the question I want to leave you with is this. What fundamental survival skills are we losing by trusting those invisible defaults?
That's a great question.
When infrastructure is just magic, we lose the muscle memory of how things actually work. If that heavily abstracted invisible layer ever fractures, who is left that actually knows how to diagnose the underlying hardware? Are we blindly wandering into the next great invisible infrastructure crisis without even realizing it, simply because the magic is just too convenient to question? Something to chew on the next time you order a humidifier at midnight. Thank you so much for joining us on this deep dive. We'll catch you next time.